Watch the water closely, not the mountain, not the smoke curling into the sky above it, the water. Because on this island, the ocean has learned to move without asking permission from the ground first. No shaking, no countdown, no siren cutting through the night, just a wave, arriving out of a calm sea, faster than anyone could ever hope to run. Right now, in the middle of the Sunda Strait, a thin column of gray ash is rising from a volcano, barely 100 years old. It reaches only about 100 meters into the sky. Modest, almost forgettable, next to the great eruptions this region is known for. But scientists are not looking away from it. Not for a second, because this is Anak Krakatau, the child of Krakatoa, and this island has already shown the world exactly what it's capable of, without warning, without mercy, and almost without a sound. Let's begin with the detail most people would miss entirely. White steam rising from a volcano is water meeting hot rock. Routine, background noise, the mountain simply breathing the way it always has. Gray ash is something else entirely. It means fresh material is being fractured and thrown upward from deep within the system. It means pressure is on the move. It means the volcano's internal balance has shifted, even if only slightly. For weeks now, monitoring stations around this island have picked up a cluster of small, shallow earthquakes clustering directly beneath the crater. Thermal sensors have flagged patches of the slope, running noticeably hotter than normal. Gas detectors have measured sulfur venting in places that had been silent for months. No single signal here spells disaster on its own, but together, layered one on top of the other, they describe a mountain under strain. And a mountain under strain is a mountain capable of failing in ways far more dangerous than an ordinary eruption. To understand why, you need to understand what makes this volcano fundamentally different from most others on Earth. Anak Krakatau isn't sitting on solid, ancient bedrock, anchored and stable after centuries of settling. It's a young cone, built eruption by eruption, from loosely packed layers of ash and broken rock, rising steeply out of open water on all sides. That structure is inherently unstable by nature, and when instability like that meets rising internal pressure, the danger isn't only what erupts upward into the sky, it's what can give way sideways, beneath the surface, out of sight. Scientists call this a flank collapse. An entire section of the volcano's slope can slide into the sea all at once. Not an explosion, but a landslide. Millions of tons of loose material displacing the ocean around it in a matter of seconds. And when that much water is forced to move that quickly, it has to go somewhere. It rises. It spreads outward in every direction. It becomes a wave. This is what researchers have come to call a silent tsunami, not because it makes no sound when it finally reaches shore, but because the mountain gives almost no warning before it triggers one in the first place. An ordinary tsunami is usually born from a major earthquake, and an earthquake, however brief, is itself a kind of alarm. Ground shaking for even 30 seconds gives coastal communities some window, however narrow, to move toward higher ground before the water arrives. A flank collapse offers no such courtesy. It can happen underwater, in complete darkness, with no major tremor to announce that anything has changed. The first sign anyone on shore receives may be the wave itself, already moving toward them. This isn't theoretical. It happened on this exact volcano once before, and the world watched the aftermath unfold in real time. In December of 2018, part of Anak Krakatau's flank collapsed into the strait during a period of ongoing volcanic activity. There was no major earthquake strong enough to trigger the region's tsunami warning systems, which had been built primarily to detect quake-driven waves rather than landslide-driven ones. The waves that followed struck nearby coastlines with almost no notice, at night, during a period when shorelines were unusually crowded with people. More than 400 lives were lost that night, and thousands more were injured. It remains one of the clearest lessons in modern volcanology. Not every tsunami announces itself before it arrives on shore. That event permanently reshaped how this island is watched today. Scientists no longer monitor for eruption alone. They track the physical shape of the volcano itself, watching closely for any sign that its slopes are shifting toward the kind of failure that struck without warning in 2018. To understand where this island truly came from, you have to go back even further, to 1883. The original Krakatoa erupted with a force that reshaped the entire region around it. The sound of the explosion was heard thousands of kilometers away, one of the loudest sounds ever recorded in human history. Much of the original island collapsed into the sea during the eruption, triggering a series of massive tsunamis that devastated coastal communities throughout the strait, with a death toll estimated in the tens of thousands, among the most destructive volcanic events ever documented on Earth. Decades later, from the flooded caldera left behind by that catastrophe, a new cone began quietly rising from the seafloor, unnoticed at first. By the 1920s, it had broken the surface of the water, and it has continued growing, eruption by eruption, ever since. Its name reflects exactly what it is: a child born from its parents' collapse, inheriting both its location and, more dangerously, its underlying instability. That inherited instability is precisely why today's small ash plume matters so much to the people studying it. This volcano doesn't need to produce an eruption on the scale of 1883 to become deadly. It only needs an unstable slope, a push from within, and open water waiting patiently below. Naturally, a story with this kind of history attracts myths, so let's address a few of them directly. This current activity is not a sign of an imminent, catastrophic global eruption. Small tremors and gas venting are simply part of how volcanic systems normally release built-up pressure, and the vast majority of episodes like this one resolve quietly, without any major event ever occurring. This volcano is also not connected to unrelated fault lines or eruptions elsewhere on the planet, despite claims that occasionally circulate online. Volcanic systems are local phenomena. This one's activity begins and ends entirely with its own internal plumbing, and a Level 2 advisory does not mean evacuation is imminent. In Indonesia's alert system, it signals heightened vigilance, a recommendation to stay well clear of the immediate crater zone and remain alert for further updates, not a signal that catastrophe is guaranteed. Authorities adjust these alert levels often, in both directions, and doing so is the monitoring system functioning exactly as it was designed to. So what does all of this really mean? Watching that thin gray plume rise quietly into the evening sky tonight, it means scientists are doing exactly what should be done, not reacting to one ash column in isolation, but reading a pattern carefully. Earthquakes, heat, gas, the slowly shifting shape of a fragile, unstable slope, all of it layered against a history that has already shown, painfully, what this island is capable of. The lesson of 2018 was never that this volcano is somehow uniquely cursed. It was that the sea can rise without ever asking the ground to shake first, and that the only real defense against a threat like that is constant, careful, patient watching, especially when everything on the surface looks calm. Right now, the child of Krakatoa is stirring, not raging. And somewhere on that island tonight, instruments are quietly recording every tremor, every degree of rising heat, every subtle shift in that plume, because the people watching understand something the rest of us are only now beginning to grasp. The most dangerous volcanoes aren't always the ones that roar. Sometimes, they're the ones that whisper.